Hello friends, in this video we are going to calculate the majority and the minority carrier concentration in the extrinsic semiconductor. So, procedure of calculation of majority and minority carriers in extrinsic semiconductors has two parts. So, procedure. So, it has two parts. The part one is that when the doping concentration is very much greater than the intrinsic carrier concentration, that is Ni. So, for this case, let us take a N-type semiconductor. So, if in an N-type semiconductor the doping concentration is very much greater than the intrinsic carrier concentration, then we can write doping concentration in the N-type means the concentration of donor ions, that is Nd, will be very much greater than Ni. So, we can let us assume that Nd is nearly equals to 10 of Ni, that is the intrinsic carrier concentration. So, we can write that the majority carrier concentration of the N-type semiconductor is electron, denoted by N suffix N, will be nearly equals to this donor ion concentration, that is this Nd. So, this is the majority carrier concentration in the N-type semiconductor when the doping concentration of the N-type semiconductor will be very much greater than the intrinsic carrier concentration. Now, according to the mass action law, we know that the minority carrier concentration in the N-type semiconductor, that is holes of the N-type, that is Pn, will be equals to Ni square divided by the majority carrier concentration, that is Nn. So, this equation can be written as, in the place of n suffix n, we can put the Nd value. So, this equation will give the minority carrier concentration in the N-type semiconductor when the doping concentration, that is Nd, is very much greater than the Ni. Now, this is for the N-type semiconductor. Similarly, we can do for the P-type semiconductor. So, let us see the P-type semiconductor for the same case. And we know that in P-type semiconductors, the majority carrier are the holes, that is P suffix P, and the minority carrier concentration will be N suffix P. Now, in this case, we have already taken that the doping concentration should be very much greater than the Ni. So, for the p-type semiconductor, the doping concentration will be equals to the acceptor ion concentration, that is Na, and this Na is very much greater than Ni. And we also know that from the p-type semiconductor, the hole concentration, that is the Pp, is nearly equals to the acceptor ion concentration, and this will give the majority carrier concentration inside the p-type semiconductor when the doping concentration will be very much greater than the intrinsic carrier concentration. Similarly, from the mass action law, we can find the value of minority carrier concentration, that is Np is equals to Ni square divided by P, where Pp will be given by Na. So, this equation will give the minority carrier concentration in the p-type semiconductor for the doping concentration is very much greater for intrinsic carrier concentration. So, this is all about the procedure of calculation of minority and majority carrier concentration part 1. Thank you.